So what you're going to do is you're going to get on your Project Lead the Way. If you look at your agenda, the way that I've done it is I put all the assignments in here by number. So you'll see those. So if you look on here, we've already taken the fuel notes. So you should have those attached. You will need to go in and do vocabulary list number 4. Write those in your ISM book. And then you need to go to activity 1.3.3. And you're going to do questions 11 through 22. If you forgot how to get there, you're going to go to Horry County Schools. Get on your Learning Commons. Project Lead the Way. Share my screen so you can see it. Once you go into Project Lead the Way, you're going to look for 1.3.3. So you've already done some of it already. What we're going to do today, you're going to do questions 11 through 22. So if you go here and you go here, you're going to see your questions. And what you're going to do is use the PowerPoint that's attached. And your job today is to answer questions 11 all the way. You can probably do the hot box too, since we did the hot box yesterday. So you could go ahead and do 22 through 29 because we did that yesterday. So you could use that. Now what you need to do is just pause your computer or turn off this presentation and come back to it. And we are going to go over the answers to that. Okay. All right. Is everybody ready? Okay. So first part, and what I did is I'm just going to go over this really, really quick. This has some of the answers. So if you'll look at yours, you kind of will see them. So if you look up here on my notes, I have the first law of thermodynamics, that nothing can be created or destroyed. Now it can be changed. And to be able to change, you have to have some work done on that system for that to happen. They gave an example in the PowerPoint about a bicycle pump. How does a bicycle pump go along with the first law of thermodynamics, Elijah?
You're taking kinetic energy and then you're compressing air and then you're turning it into another cylinder.
Very good. Okay. So then I went over the second law of thermodynamics that's talking about thermal energy flows from hot to cold. So, Australia, can you explain to me the pizza in the hand? You remember what it was talking about with that? So if you have your hand on a frozen pizza, where's the heat coming from? The frozen pizza or your hand? Your hand. If you have a cooked pizza and you grab it with your hand, where does the heat transfer from? Pizza to your hand. That's an analogy of hot to cold. Okay? So that's the second law of thermodynamics. And they also talked about entropy. What is entropy? What do you have on your definition of entropy? Okay. And beside that, if you would write order to disorder, they gave us an example of that in the PowerPoint where it was talking about firewood. How firewood is order, and then when you burn it, makes it disorder. And that was the example that they gave there for entropy. Okay. Hugh, convection. Okay, and what two examples did you do?
Radiator and ice melt.
Okay, that's a good one, and I put wet. Same thing, right? Change it, ice melting is right, I like that, I'm gonna add that to mine. All right, conduction. Next.
The transfer of thermal energy within an object or from molecule to molecule,
And the two examples that you wrote down?
like a on a stovetop or ice and pizza example as well, like a handle pizza.
Fantastic. And then it didn't really give us what radiation was, but radiation is kind of like, when you're talking about the sun, you're talking about fire. Yes.
Do you want me to give my definition? Because I got one for.
Sure, go ahead.
So I got radiation is the transfer of thermal energy through a medium, like even empty space, via electromagnetic waves.
Very good.
That's what I got.
That's good too. I like that electromagnetic wave. You can't really see them, can you? But you know they're there. Okay, so then they gave us in there a formula of thermo energy transfer equation. So the first one they gave us was this Q, which is energy transferred in joules, to M, which is mass of the material, C is specific heat of the capacity, which is in joules, kilograms times C, and then the change in temperature. Not only did they give us that one, they gave us the other two on the bottom. You have P equals Q, change in temperature. P equals K times A times change in temperature over L. And K is P times L and A times the change in temperature again. K being thermal conductivity, A being area of thermoconductivity, and T is the thickness of material. Did everybody get that far? Okay, so now what I'd like you to do is I'd like you to take your board and your marker. And what we're going to do, and that should cover most 11 through 16, 17, all the way to 17. So then the next thing is where they were asking you for equations. So the first thing I want you to do on your board is I want you to write out the variables that you have written down in your ISM book. And I would like you to show me 22. Yeah, so what we're doing here is we're taking what they say. You're pull it up on your computer. So right here, it gives you this here, and it's asking you for the known variables, and then list the unknown variables. Select the equation, apply it, and then solve. So I would like you to do 18 through 22, the best that you have.
This is what way.
Okay, open up yours to that activity. And go to that question. And what they'll do is they'll give you a word problem. And what you're doing here is you're writing down the variables that you have based on that word problem. Okay? 1.3.3. Scroll down. We're going. Right here.
What if we 18 through 20, 21, 22?
Yes, that's what I'm asking for you to put on here, please. 18 through 22, you're going to put on your board.
So if you want to go to the board and look at what I have and see if it makes sense of it with your board. Okay, so she gets started and she gets.
That's a lot of math.
Okay.
She did. I don't control it.
So you can erase that, please. Start your build.
Let's look at 900.
900 is one of the variables inside the equation that you have from,
No, it's 90.
no, one's 90 and one's 900.
Well, I did not see all that.
It says, like, you can't see, so you're not removing the
I
variable.
thought they were in these drawings here.
Yeah, it's, yeah, I'm sorry. I'm still confused.
All right.
Wait, yeah, I got that 900 and the other number.
Okay, so let's look and see what we've got here. So the formula that we're using is Q, MA1, which MA1 is 1.0. What is CA1 stand for?
Right here. CP A1, 900 joules.
Where'd you
That's where
get
I
that
get that
from?
From the reading, from the paper itself. Let me see if I can find it. I have that in here.
So mine said was the 1 kilogram for the 9 and 20.
So, 1 piece of aluminum milk that's 90 degrees Celsius and has a 4 liter of water at 25 degrees Celsius. What is the final temperature? So if you think, this right here is the aluminum, right?
Yes, sir.
This here is the aluminum, but this is the capacity of it, the CP of it, which is a number that goes along with the water. Where would you find that in? Okay, so let's go back. Go back to the PowerPoint. All right, sir, are you ready to use her? So look at that, please. And we're just doing the math. Let's sit right here and look at the math.
Does it matter which one we build?
Yours, I don't think so. It should look like this when I get done. So you're waiting for the board, correct? You just waiting for the board. So what you're doing is you're gonna take your parts apart.
Relax.
And you take
Which one are you building?
I don't know.
I figure out which one you're building before you start swap out stuff.
Do it. You're waiting. All right, sir. So. Are you confident?
Which one do I want to build?
Good. So look at this problem here, and this will help. All right, sir? I think I have given you everything you need.
Okay, so no matter what,
And honey, I think I've given you everything you need. I think I have everything on. Fantastic. So
Yeah.
let's see if you can get it built. I just got his. What you're going to do, ma'am, is you're going to be doing this. So you will need to go into, I think it's Tuesday's assignment, and open that up and start building that. with me.
no matter what, you have to go by.
And that. And the long one. We need to have the wheels. And this wheel. Wait, sir, you need to go for one of the doors.
Twist them a little bit.
Which one's the body?
There's mine. Wait, where'd she get 8? Why is she 7?
Yes,
I have a question.
yes.
So I'm getting all the way to the right. You're the background, those two voice, the thing that you noticed.
It does in the PowerPoint.
You know?
So what you're supposed to do is look over the PowerPoint first, and that would show you how they found these two variables. These are constants.
And then when you do that here,
Yes. So the only thing that I did is I was just working out the problem, trying to figure it out. But this is here where I really had the problem. Okay? So then I took my 8100, and where did I get the 8100 from? Is from up here. And then what I did is I subtracted 900,
she's this.
and then I divided by this number here. And that's where I got, if you take this number and divide it by that number, you should get that one. 1672. Got it from here.
This one's
So this is this.
Correct. Exactly.
I just am really confused on is that supposed to be a T?
Yes, it's a TIA.
Okay. So I'm over here with 7.
Oh, I gotta stop this. Hold on a second. I'm sorry. Give me just 1 second. I need to stop it. I forgot it. Replace it. Yeah, let's do that.